toString equals all right, cloning. So the idea behind what's called cloning is simple, that you have an object here. The object here, and then you want to make an exact copy or a clone of it with exactly the same content. And so keep in mind that if you just make an assignment, then you get a reference assignment. So if you just make the normal assignment where you say clone equals E, then what you would get is just a new reference. That's not what we want. We want to make an exact copy. Now it turns out there's a perfectly good method for that called object.clone, and what it'll do is it will make a new object of the same type, and then it'll copy over all of the fields. And it seems like that's all that should be required. And so why is there even a slide on it? But it turns out that cloning is incredibly complicated, much more than one thinks. And because it's complicated, and because there's subtle things that you have to get right, the object.clone method is protected. What's it mean to be protected? That means that a subclass method can call it. But that's not how clone is meant to be called. What you expect with clone is that anyone can call clone in any code. So the first thing that you need to do to call clone is you need to redefine it and make it public. And that way you say, okay, I know what I'm doing, objects of my class are clonable. And then you can call super.clone, and then that way you get what object.clone does. It makes a new object and copies all fields. But there's more. Object.clone is really nervous, and so not only is it protected, but it also checks that the class that's being cloned implements the clonable interface. So the clonable interface is here, and you can see it's an interface with no methods. So why on earth would you want to have an interface with no methods? That's kind of a weirdness that is not very common. There's a couple of interfaces. We're going to see another one of that today. It's called a tagging or a marker interface, and it's only there so that some code, in this case that's the code that's inside object.clone, can check if X implements clonable. And in that case it says, okay, the object belongs to a class that implements this tagging interface, and so that means that the implementer of this class somehow knows what they're doing. That's all that it proves. So if object.clone finds out that X belongs to a class that wasn't implementing clonable, then it throws a clone not supported exception. That seems fair enough. Then it says, okay, I can't possibly clone this thing. The designer of this class didn't say it's clonable. Now, interestingly, clone not supported exception is a checked exception. That means you need to do something about it. So what this method does is it calls super.clone. Then it catches the clone not supported exception, because in this case it won't happen since we are clonable. We've implemented the clonable interface. So it doesn't much matter what you put here, because it will not happen, or so we hope. And so here we're returning them. That's one way of doing it. The other thing that you can do, and that's often a better way that for some reason I didn't put in the slide. Sorry, let me come back here. Is you could, instead of doing all this try-catch nonsense, you could just put in throws clone not supported exception here, and then that way the caller of the method would have to be prepared for what might happen in that case. The reason that's not a bad idea is that the employee class, sure, it knows how to do the cloning, but what about its subclasses? There may be some issue with some of the subclasses, and so this way you leave that possibility open. So I would generally recommend that, and that's the recommendation certainly for the lab. I'll rewrite this section. All right, now the next thing. Remember what I just said, what happens when object.clone does its thing. Object.clone is very simple-minded. It makes a new object, and then it moves over each of these three instance variables. And when it does that, it does not clone them, it just copies them. So now over here I have the name, the original and the copied name are both references to the same string. And the original and the copied higher date are both references to the same date object. So you can see that the original and the clone are still somewhat entangled. Now, does it matter? Is there any harm done by them sharing this string? And it turns out no, because strings are immutable. There's no way for you to really know the difference between them sharing the string or each of them having their own string. But the date object, and that's why I've chosen this ancient date class, the date class is mutable. So if someone were to change one of these dates, then the other one would be affected by that, and that's not what we think a clone should be. The clone should be completely independent of the original. So that means that employee.clone is actually not implemented correctly yet. A clone method has to make a copy, or another clone really, of all of its mutable state. So what employee.clone should be doing is shown here. It's okay to share the string, but it should also make a clone of the date. Yeah.
You just said about the try-catch. Should we actually throw out an exception, or?
No, you shouldn't do anything. You simply declare that that exception might happen. Object.clone threatens that it might happen, and so your program will compile. At any rate, even it's okay for you to. I shouldn't have said it like that. It's okay for you to say throws this or that exception in any method, even if the method doesn't throw it. So let me actually, as a sidetrack thing, because it's something. So let's say I'm writing a method. And now I say it can throws a whatever array index out of bound exception. Okay, and now inside here I just return 0. Will it compile? So it will compile even though I'm not throwing the exception. Why doesn't the compiler say, hey, you should not be saying that because you're obviously never throwing that exception? Well, at runtime, it's never going to happen. So shouldn't the compiler give me a warning or an error and saying, how come you're never throwing this exception? The compiler is supposed to be helpful, right? Why am I saying I'm throwing an array index out of bounds exception when in fact I'm not throwing it? Should the compiler say, weirdness going on? And there's a reason why the compiler will not give you any warning or error. And my question is, what is that reason? It has something to do with object-oriented design. Wait. The reason is that this way a subclass that does something different can throw the exception. Because if you didn't have it, and then you had a subclass, So if this here is my superclass, and then you have a subclass, and over here now overriding. When I override a method, I can say I'll be throwing fewer exceptions, but you can't now throw more exceptions. Because otherwise, if the subclass threw more exceptions, then the exceptions couldn't be tracked at compile time. So by putting this thing here, it allows the subclass to actually throw this exception. And then it might say throw new AAI out of bounds. So it's important that the superclass keeps that possibility in consideration, and that's why the compiler doesn't complain. So if, on the other hand, you declared your class as final, then it doesn't make any sense. In that case, you would take it out. And I believe the compiler would give you a warning. I don't actually know that, but you could try that out. It should give you a warning. All right, so so we want to achieve this picture here, and the code for achieving that is simple enough. I need to call super.clone, and I need to call hiredate.clone to clone the higher date, and then I need to wire it up in the clone. So the higher date of the clone is the clone of the higher date. And so it's not really difficult to do. What you simply need to do is make an inventory of all of your fields, figure out which of them are mutable, and then clone them recursively. The compiler can't do it automatically for you, because there's no indication in Java whether a class is mutable or not. You, the programmer, need to know that. The Java compiler doesn't. And B, there are other more complicated scenarios, and you'll see one in the lab, where there's no way for the compiler to make these decisions. So that's what you do to implement cloning. So another weirdness about cloning is that object.clone is the most paranoid method in the entire API. Clone is protected. Clone insists that objects are clonable, and clone throws a checked exception to really make sure that that exception cannot be overlooked. But now, if employee says, I want to be clonable, then it implements clonable, and that means all of its subclasses must also have that responsibility, because you cannot, in a subclass, unclone yourself. And so if you extend a class that defines clone, you must redefine clone, because you are picking up that cloning that by itself probably will not do anything. And so tagging interfaces are actually a very bad idea, because by tagging the class, the entire hierarchy that lies under it is also automatically being tagged. And so you should never do that technique in your own code unless you're really sure that they are inherited. Nowadays there are better ways of doing it, but by using what's called annotations. But cloning is all the way back from Java 1.0, when people didn't really understand that stuff so well. Now, is cloning, having said that, so has any of you ever implemented clone for anything? No, right? When you look in Violet, it's in the source code. I believe lots of things are clonable, because Violet uses this the cloning mechanism. So when extensively, like all of the buttons in Violet have like a node or an edge. There's like a prototype, and then when you push the button, what it simply does is it clones whatever that thing is, and hey, there is your new node or edge of that same type. And that's kind of elegant. Maybe it's not so elegant to use clone for that, because cloning is so weird. In the JDK, cloning is not very common. So most classes elect not to be clonable, and that's probably a good idea. So you want to have a good reason why your class needs to be clonable before you get into that. It's a very subtle kind of thing that's easy to get wrong. The next thing that's kind of in a similar vein is serialization. It's also an important feature of Java that has many uses, but it's also kind of tricky. So let me explain what the motivation is. Let's say you have some kind of a data structure, and here I'm just using an array of employees, which may or may not, that's probably not the most typical use of it, but just because it makes the code easy. So now I'm building up this data structure. It has maybe some collection, it has some stuff hanging off it, and now I want to save it out, and here I'm saving it to a file. The file has to be an object output stream, so I'm first making a file output stream, and then I use the object output stream decorator, usage of the decorator pattern, by the way. And then I write out this object here. And so staff was an array that contains inside itself 2 objects. I write it out, and this single call here writes out the array and both of the objects that are inside to this file in some binary format that you don't need to really understand. And then I close the file, and now I'm done. Then later on, I can read the thing back in. I'm not showing you that, but it's in the book. So there's the opposite code for making an object input stream, and then you read it back in. Now, so this way, you have written out a whole network of objects to a binary data structure. What this thing was really intended for is not so much to save things to a file and read them, but to save them to a stream of bytes, send that stream of bytes across the network, and then get it back on the other side. So this might be of some interest to the collab violet people. So you could perfectly well use that. If you did not want to think about a protocol where you write down all of the things in ASCII, you could perfectly well take an object that describes the command, serialize it, and send it over to the other side that way. Now, the serialization gives you something that's binary. Then you'd have to figure out how you're going to send something binary across, but you could just base 64 encode it and send that over. That would be a perfectly reasonable way of implementing that particular thing. In the simple version of Violet, not the one that, not the .16b, but the one that's in the book, I do use serialization to save the diagram as well. The problem, well, I'll come to the problem later. All right, so basically what serialization does is it takes a tree of objects. So I have one here. It takes like a whole tree of objects, or a graph of objects, I should say, because it doesn't have to be a tree. It can have cycles. It takes a graph of objects and turns it into a mess of bytes so that later can be reconstructed. So notice also that there's no method that has to be defined. I was able to do this here without defining any method at all in the employee class. With clonable, you have to implement the clone method. With serialization, you don't have to implement anything, but you do have to implement the serializable tagging interface. Serializable is another interface that has no methods at all. It's a tagging interface. And so employee, you just add implement serializable, and that's the end of it. The virtual machine knows how to serialize anything. So here's how it does it. And I'll just show you from here. So when you say write object staff, then the virtual machine goes on and says, all right, so I'm following this reference and I find an object. What is this object? It happens to be an array. Now it's going to write out that this is object number 1. Each object gets a serial number. That's why it's called serialization. So it says this is number 1. And it's an employee array. That's the type of it. Then for an array, it's simply going to now go on and serialize each of the elements. So for this one, it's going to say, this is element number 2. Then it's going to serialize the name, which is a string. It's just going to write out the string. It's going to write out the 35,000. It's going to then look at this reference. It's going to write this reference and saying, this is employee number 3. Notice that this employee class is a little bit different than the one we had before. Here, just to show off the cycles, each employee has a buddy. That's also an employee, just for show. Okay, so this guy's buddy is the other one, and the other way around. So it's going to write down this buddy as number 3. And now when this one is written, things get to be a little bit more interesting. The name is written, the salary is written, and its buddy is written. But that buddy was already saved. And so now, in order not to have an infinite output, the serialization algorithm says buddy is the reference to already known object number 2. It's not going to write the object out again. It's going to just say reference to already known object. How does it know the object was already known? It must somewhere have a set or a hash table that has, all of the already known things. And that's what serialization does. By the way, here, when the next array object is written out, then the same thing. It says reference to already known object number 3. So the trick to save a cycle of objects is that the first time you see an object, you write it out fully, and all the other times you see a reference to the same object, you put something into the file that says reference to already known. You have a question?
Yeah, I was just going to, so it sounds like in this particular case, because there's this buddy field that will write out the third object in the process of writing out the second one.
Yes, that's in fact what happens. So it's kind of like in HTML when you open up like a new, like you can have an li and an li, so to speak. We can have a div and a div. That's a better example, right? Yeah. But so it keeps track of where it currently is in the nesting level. Yes.
So when you create the first employee, not that employee's buddy.
Oh, you presumably have some set buddy method. That when you look at the sample code in the book, you can't have it in the constructor, right? Because one of them has to be constructed first. But the way that I have it is I construct them with null buddies, and then I have a set buddy method where I say a.setBuddy b, b.setBuddy a. Yeah. So what you're saying, that's interesting. That I had never thought about it. That you could not have a cycle when you have only immutable objects. Without a setter, you can't make a cycle.
So what you're saying is you create a second employee and then you...
Then I call first.setBuddies of second.
Right.
Yes, yeah. And I'm just tossing in as a random fact that if you have a bunch of linked objects, all of which are immutable, you will never have a cycle. Because the only way that you can put them in is by if the network has to be established through the constructors, then that's all you can do. Anyway, I don't want to dwell on that part. So that's how serialization works, and it is conceptually basically simple. There are a couple of technical wrinkles. Sometimes you'll find lots and lots of classes are serializable. It's a fairly commonly implemented interface because there is this general desire that if you want to distribute work, then you should be able to send an object across the network to somewhere else. And so you'll find that essentially all the classes that you work with are serializable, unless there's a good reason why they can't be. Like print stream is not serializable. It just does not make sense to send a print stream across the network. One of the classes that's not serializable, even though maybe it should be, is buffered image. And the reason for that is that buffered image is just fiendishly complex. There's all sorts of different ways of storing the pixels, and I think the person, maybe someone tried to make it serializable and then they just lost the will to live. They just never did it. There's no technical reason why it couldn't be done, but there you are. Now what happens if you have a class that has a buffered image field? Now probably there's no particular desire to serialize every pixel. If you just remembered where the image came from, maybe you have the file name or the URL, you could just serialize that. Or if you really needed to, you could turn the image into an array of pixels and serialize that or something. And so, but whatever, you definitely do not want to save buffered image because there's no way of doing it. And if you have a field that is not serializable, then trying to call write object will throw an exception. So in that case, what you do is you mark the field with a keyword. There's an actual language keyword for this called transient. And that means the serialization algorithm should just skip that field. So the designers of Java, I think this happened in 1.1, thought that serialization is so important that they were willing to invent a whole new keyword to support it. And here it is. So what if you do want to now do something special to save, say, the pixels of this image? Then you have to do something very strange. You have to supply two methods whose names are hardwired. You have to call them, even though they're not defined in any interface. You have to call them write object and read object. They have to be private, and then they have to be able to write and read that extra state that you want to write or read. There's an example of that in the, is there an example in the book? I'm not sure. There used to be an example in the book but I had to take it out because the class that they had ended up being serializable in Java 1.6. So what you have to do in these methods is, and I just say that because you may get to that in the lab if you work fast, you have to call write default object and then manually save the other data by calling write string or some such thing. All right, so that's what I wanted to show. And before we get into the lab, both cloning and serializing have a very strange thing, namely, they both bypass constructors. In all other situations, you can only get a new object by calling new. At some point, something had to call new to get a new object. But with cloning, you get an object that was produced without going through the constructor. With serialization, you can serialize something into a byte array and then deserialize it from there, and presto, you have a new object without ever having called clone. With serialization, they've lived to regret that, because it is possible to attack a service that wants a serialized object by passing in an object that was nastily crafted to attack the system. And that has actually been done. So there's a bunch of attacks on the Java virtual machine, very successful attacks that use the fact that someone ran some open service that says, here is the stuff that you need to work on, and then they fed it a malicious command that where they made a subclass, they overrode that subclass somewhere to call some system service like to shell out to the system or something. So serialization is something that has given the Java folks a huge amount of grief, and in hindsight they wish they had never done it. So one of the chief Java designers said, and when he was asked at the last Java conference, what did he think was the single worst design decision in Java? He said, without even thinking, serialization. So it's interesting to know that what seems to be like a reasonable thing to do is complex and fraught with danger. Nevertheless, they are part of standard Java, and you should learn them. And so I put together this little lab. So, yeah, go ahead.
A reflection, you can also create.
A reflection, it turns out, is more localized, and it has not been an attack surface. The problem with serialization is that you have to realize that it's completely untrusted, and the only way that you can deal with it is by signing your byte stream. So if you have a package of bytes that you hand over to someone else and say, here is a serialized object, go deserialize it, whoever takes in that object really needs to know where is it from, and how do I know that those bytes have not been tampered with. Whereas reflection is captured by the security manager, so you can't just say, I'm running with the security manager, I'm simply not allowing reflection. And in that case, you can turn off the feature. There's no way for you to turn off. I mean, lots of things depend on serialization. It's not easy to turn off. All right, let me find my lab. Come on, computer. Oh dear, I didn't put a link up for the lab, so I have to show you how to get to the lab. Now, go to the lecture 20, the one that you had last one, and just change the 20 to 21. And here it is. So, there's nothing to it. I'm giving you a person class, and I want you to implement Clonable. And you will see, the various pitfalls that you run into. And then the person class that you have designed in the first step, just declare it as serializable. And that should be enough to do the serialization. And then if you have extra time, then I'm just having you do this thing to add a non-serializable instance variable in there. I kind of doubt you're going to have that time. So go ahead and have at that, and then we'll talk about how you're doing that.
In the instructions, it says to put the code in the lab 20 subdirectory, but the report in lab 21.
Oh, that's a mistake.
Okay.
So they should both be in lab 21.
Huh?
Yeah, here, that was just a typo, because I copied and pasted, so it should be lab 20. I can probably fix that real quick.
Sure.
Um,